Okay, this is the second video on everything you need to know in order to solve quadratic equations. Here we're going to talk about the distributive property. So here's the best way, I think, of imagining the distributive property. Let's say you have a bag, and inside your bag you have a couple of x's and 3 o's. And you've got another bag, a couple of x's and 3 o's. And you've got another bag, a couple of x's and 3 o's, and one final bag, a couple of x's and 3 o's. Now, if you were to dump out all of the bags, you would have 1, 2, 3, 4, 5, 6, 7, 8 x's, and you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 o's. Let's write o's like that. We'll make these little dots in the middle. Okay, so you have 8 x's and 12 o's. Now, the distributive property is another way of writing this. If I wrote 4, 2x plus 3 o's, then this means I have 4 bags. Each bag has 2x and 3 o's. So 4 times 2, 8x. 4 times 3o is 12o. And I have 8x and 12 o's. Okay, so let's do another example here. What if I have 3y and, actually let's go back, let's just go for 3. And I have y minus 7. Well, the 3 hits that term, and the 3 hits that term. So it's the same thing as 3 times y. The sign was going to come down here, and then 3 times 7. So 3 times y, we just write 3y. 7 times 3 is 21. So 3y minus 21. Okay, go ahead and give this one a try. 5x plus 2. Great. So 5 hits the x, turns it into 5x. 5 hits the 2 and turns it into 10. Now we can practice this with real numbers, right? If I have 3, 8 plus 1, I can solve this normally. 8 plus 1 is 9. 3 times 9 is 27. Or I can solve this using the distributive property. 3 times 8 is 24. 3 times 1 is 3. 24 plus 3 is also going to be 27. So you get the same answer either way. Okay, let's go now and solve something like this, or work on something like this. What if you have x plus 2? In that case, the x hits the x, and it turns it into x squared, and the x hits the 2 and turns that into x2. But normally we don't write x2. Normally we change the order and write 2x just because, I don't know, it looks better or something. Okay, now you can also imagine it this way. You can also imagine something like this. This is x wide, and this thing is x plus 2 wide. And so this is essentially just an area problem. So we're multiplying these things together. X times x is x squared. And then this, remember, is x wide. 2 times x is 2x. So you've got x squared plus 2x. So you can think of it as an area problem. Okay, let's go now and do one for you to practice on. Let's do 2x, 3x minus 1. Okay, so we're going to use the distributive property. Let's have 2x hit 3x and 2x hit negative 1. So we're going to have 2x times 3x, and we're going to do this one. That minus sign comes down. We're going to have 2x times 1. All right, 2x times 3x, remember with our exponents review, 2 times 3 is 6, x times x is x squared, 2x times 1 is just 2x, so we got 6x squared minus 2x. Okay, let's do something like this. Let's say we've got 5x, and we have 7x plus 2. 5x times 7x, 5 times 7 is 35, x times x, x squared, 5x times 2, 10x. Now, you can also visualize this as 5x, and then 7x and 2, 5x times 7x, 35x squared, 5x times 2, 10x. So you get 35x squared, 10x. Now, one thing you might be wondering is, can you combine those two things together, 35x squared and 10x, and make it something like, I don't know, 45x cubed? Well, it turns out you can't. And the reason why you can't is this. In x squared, imagine this as square. Now, 35 squares means I've got a whole bunch of squares all over this. I've got 35 of them. Now x's, the best way of visualizing x's are like long, skinny blocks like this. They're not square. So I have 35 squares, 10 x's. You can't combine them together. If you were to write something like 45x cubed, then you would have 45 of these three-dimensional cubes, which are hard to write, and they don't match. This and this are not equal. Okay, so let's now talk about going backwards. Let's say you have something like x squared plus 3x. Right now we're going to do the opposite of the distributive property, which is factoring. Now x squared is made up of x times x. 3x is made up of 3 times x. Now factoring is looking at these things and saying, what do they have in common? Think of this as though these two things were on a date together. And you know, on a date you'll talk and find out what you have in common with each other. If these two started talking, they'd find that they both have an x in common. Okay, now the first step of factoring is you find out what they have in common. The second step is you put the common thing outside the parentheses. So this is what I mean by that. Okay, so they both have an x in common, so we're going to put an x right here. And inside, the leftovers get dropped inside the parentheses. So here's a leftover, going to drop that in. Here's a leftover, going to drop that in. And the plus sign comes straight in like that. So I have x parentheses x plus 3. Now, you can always use the distributive property to check. Let's go ahead and do that now. If I do x times x, I get x squared. If I do x times 3, then that's 3x. And so you get what you started off with once you do that check. Okay, let's do this one. I want you to factor this guy. X squared plus 7x. Great. So x plus 7, and we're done. Okay, let's do something a little bit harder. Let's say you have something like 2x squared plus 6x. Well, 2x squared is 2 times x times x. 6x is 2 times 3 times x. Let's check what they both have in common. They both have a 2 in common. They both have an x in common. And so, again, the process of factoring is put the common thing outside the parentheses, and the leftovers we chuck in here. Remember to copy that sign. Here it's a plus, so we bring that plus down. Use the distributive property to check. So 2x times x, 2x squared. 2x times 3 is 6x. Okay, let's do this one for you to work on. Let's say you've got, let's do 3x squared. 3x squared plus 9x. Great, you may have noticed that 3 and 9, we can take a 3 out of both. We can also take an x out of both. And now here I'm asking the question, 3x times what will get me 3x squared? Well, 3x times x gives me 3x squared. 3 times what gives me 9? 3 times 3 gives me 9. And then 3x times 3 gives me 9x. And so I'm done. Okay, last one for you to work on. Let's do something like 10x squared minus 5x. Great. They both have a 5 that can go into them. 10 is 5 times 2. 5 is just 5, or 5 times 1. And now here, we're going to do, oh, and we can also take an x out of both of them. What I mean by take out of both of them is this. This is 5 times 2 times x times x. This is 5 times x. So they both have an x, so I can put the x there. They both have a 5, so I'm putting that 5 there. And now the leftovers go here. Now this one's a little bit tricky, you may have noticed. The minus comes down. The tricky thing is I've taken the 5, I've taken that. There aren't really any leftovers here. So if you run out of things here, you can always put a 1 there. Now remember 5 times x times 1, same thing as 5x, so that 1 is going to be our leftover. And now let's check with the distributive property. 5x times 2x, let's write that out. 5x times 2x, 10x, 10x squared. 5x times negative 1, negative 5x. So that and that match up. Okay, that's it for this one.